So a complex number is going to integrate real values and imaginary values. So it's going to have a little bit of both. So the format we're going to use is we're going to describe it as a plus, and then I'm going to color code this bi. Now the a's and the b's are both real numbers, and I is the imaginary number. So I is still the square root of -1. Now every number you can think of can be written as a complex number. So for example, looking at this table down here, or this little infographic down here, real numbers like -1/2, 1.37, 0, pi, those are all real numbers. And then imaginary is anything that includes an I or would include an I, like the negative or square root of -7. Complex numbers have a real part and an imaginary part. Now, one thing it doesn't really address is, well, how are then the real numbers also complex numbers? Well, like for example, -1/2, you could write that as -1/2 plus 0i. Every real number could be written as a complex number with an imaginary piece in it. So it's always going to have a real piece and an imaginary piece. With that information, we're asked to find the values of x and y that makes the equation true. So we have 4x plus 10i equals 2 minus 4yi. The biggest thing I'm going to emphasize, and it kind of highlights that on the graph there, or not in the graph, but that the color-coded information there. We got 4x plus 10i, and the 4x and the 2 are both in red for the real parts, and then the 10i and the minus 4yi are in blue because they're identifying the imaginary parts. In general, what I'm going to say is reals equal reals. So we're going to take the real part, 4x, on one side of the equation and set it equal to 2. And then we're just going to solve for x. Now, I will say this, even though this is a fairly simple step, this is a step that people often trip up on. They see a 4 and a 2 and make the assumption that x equals 2. Dividing both sides by 4. We end up with x equals 1/2. Now, the other part, we're going to say imaginaries equal imaginaries. So that means we're going to take the imaginary term on one side, set it equal to the imaginary term on the other. On the left side, we have 10i. On the right side, we have -4y times I. And we're trying to solve for y. So in order to do so, we got to get rid of the negative. So we're going to divide by negative, but we're also going to try to get rid of the 4 and the I. So we're actually able to do operations with imaginary numbers. So we're going to do divide by -4i as well on the left side. So on the right side, negatives cancel out, 4's cancel out, i's cancel out. So just because I is a number, we can do that canceling out. We've got an I as a factor in the numerator and in the denominator. Same thing on the left side. Those i's cancel out. Now we have 10 over -4. 10 over -4 we can reduce to, divide both of those by 2, and we end up with -5 over 2. So our y value is -5 over 2.